Welcome to People-Centered AI for creating responsible products. I'm Mahima Pushkarna, and I lead design at the People Plus AI research team here at Google.
Hi, I'm Sally Lim, and I'm a user experience designer on the Responsible AI UX team.
Today, we're going to share our findings from building products that use generative AI. In this session, you'll see that creating people-centric generative AI is a culture shift encompassing product processes, strategies, patterns, and even team dynamics. And so we're very glad that you're here and you're making this a part of your work. Now, generative AI has brought us to a transformational moment, one that represents a whole new paradigm of ecosystems and experiences. If you're an ML person, you'll know that before generative AI, our models needed very clear tasks. If you're in product, we needed concrete user journeys with well-defined touch points and clear actions for users. But generative AI has given people the ability to customize their AI experiences with everyday conversational language, audio, video, and even images. And while the outcomes aren't always perfect, this new ease of control is a really noteworthy advancement. So we asked teams across Google who were working on generative AI features how this new technology changed their work. We learned that in addition to specific tasks, they were now building products for open-ended scenarios and flexible user journeys. But how? For this, we need to first understand what changes in the generative AI experience once we've introduced generative AI capabilities into the products that people love and use on a daily basis. The first is expression, or how people communicate back and forth with AI systems. Instead of completing a well-defined task in a predetermined sequence, people can now interact directly with AI models. The user has a lot more control over your product's AI, and the task is whatever they want the AI to do. This makes people more vulnerable to emerging risks, and your products are vulnerable to unexpected failure modes. This reveals new expectations for user autonomy, augmenting human capabilities, and safety. Then is factuality, or how we identify inaccurate AI outcomes. Given the known limitations of generative AI systems, people will need to discern fact from fact-like, highly believable inaccuracies, hallucinations, and even deep fakes. More so, the generative variability of these models, or their capacity to produce a new output from the same input, will shape people's expectations of what is correct or what is new. So in the absence of traditional ground truth, people will now evaluate how creative or how original an AI outcome is. And this is a particularly difficult assessment to quantify because of how personal and subjective these attributes are. But as our models get better, these errors will become more infrequent and harder to spot. But even if an outcome is incorrect, people might believe these because of the inherent naturalness in their visual, linguistic, and conversational styles. It'll remain easy to ascribe qualities of self-awareness or to anthropomorphize generative AI. Now, the human-like characteristics in these AI outcomes can also introduce socio-technical harms, such as performing exceptionally well on certain subgroups and leaving out others entirely, promoting narrow stereotypes and caricaturing, and for certain professionals, the possibility of displacement. All of this has broad implications for the kinds of AI products we build, what they're used for, and how we listen and learn from people. So if there's one thing that we hope you take away from this presentation, is the idea that creating helpful generative AI happens with people. Responsible AI is work that spans the entire product development cycle, and it touches every role in the organization. At Google, we're guided by our AI principles. In addition, we've launched resources like the Responsible Generative AI Toolkit to help you responsibly use our open family of models, Gemini and Gemma. Another such resource is the People Plus AI Guidebook. We first launched the guidebook in 2019 to help user experience teams design products that use machine learning. In 2021, we updated these with patterns to implement the guidance and a workshop kit for more cross-functional collaboration. Today, We're excited to be updating the People AI Guidebook for generative AI. The guidebook is a living, breathing document with foundational concepts, strategies, and action items for user experience teams, for product leaders, but also back-end ML development and ML research roles. It sits within Google's broad ecosystem of guidance that includes our AI principles, our responsible AI practices, and material design. The guidebook has always been more about a way of working and approaching AI than it is a technical implementation guide or a design spec. It has 6 chapters that span the full product development cycle. The first 3 chapters are particularly useful if you're looking for ways to integrate AI into your product, planning data collection, model development, or building early prototypes. The second half of the guidebook is useful for evaluating prototypes, mocks, and navigating concrete challenges that show up in the product experience. Now, there's much more in the guidebook that we can cover today, but we'll continue to update this as we learn more. But to apply the guidance from all these chapters, we want to introduce a new unifying approach to your product's AI, interaction design policies. These are the set of criteria that govern the user experience and determine how your AI product responds to different inputs from people and how they can safely navigate AI outcomes. Each interaction design policy is crafted around a critical moment or a point in the user's journey where they interact with an AI system. Now, say we're using generative AI in a text editor to write an invitation. When the user invokes the text generation feature, that's a critical moment. Acceptable actions are the criteria that determine the goal-based tasks that your models should perform well for AI to add value to your product. In our example, we want our writer to be able to draft an invitation. So the AI should get all the logistical details correct, but for cultural celebrations, it should use language that is respectful to guests from different cultures. Unacceptable actions are the tasks that the AI model should not perform, even if the user unintentionally asks for these. We don't want users to experience offensive content or have the model introduce culture-based stereotypes, even if playfully. These are the outcomes that communicate the limits of our AI systems. While some errors can actively harm users and should be mitigated, weak predictions might simply reduce performance or slow the user down. In our example, our writer won't mind correcting a few words so long as they don't need to rewrite the entire invitation. For this, we have thresholds of uncertainty, which describe the necessary criteria that AI outcomes need to meet to be shown to the user. And unlike most system errors, vulnerabilities can be harder to diagnose and predict. What risks is the user exposed to when they can't recover from an AI error? Or what error-free experience today can result in a negative consequence for the user in the future without them knowing it? Our writer may unknowingly find themselves vulnerable if the invitation written with AI is offensive to another culture that they weren't familiar with, or when read in a different high-stakes context. Such criteria might only be discovered when assessing the second-order consequences of your AI product. So together, these form your interaction design policies, and you can find a workshop to use on our blog, a worksheet to use on our blog. A good interaction design policy can be used to define both UX and AI requirements, and to create a responsible AI roadmap for your product with milestones to achieve and conditions to avoid. However, the best interaction design policies are crafted from research with people. Interaction design policies are the first steps that you can take towards creating people-centered AI. But how do we translate people-centered AI into responsible products? For that, we're going to walk you through 5 product principles that span the product development process. Each of these has tactical approaches that you and your teams can start using right away. And you can use your interaction design policies to navigate these. Now, from here on out, our agenda gets demanding, and some parts will become dense. But we'll navigate these with 2 new hypothetical generative AI apps to illustrate our guidance. Our first hypothetical app is Plannerific. that helps people plan and manage any event, big or small. We know that event planning is complex and a drawn-out process. So Plannerific has a bot for brainstorming and task delegation, a generative search for venue and vendor recommendations, and a content generator for creating rich, beautiful multimedia invitations. To tie it all together, event hosts can set up an agent for their event that guests can interact with. Our second hypothetical application is Develocity. It's a generative AI-assisted IDE to increase developer productivity and code consistency. While Plannerific represents tools for the everyday user, Develocity represents software as a service and enterprise products. It's well suited for thinking through knowledge management and dependency management challenges that are typical to organizations. So Sally, how might we help event hosts and developers get started with generative AI?
Well, Mahima, we've seen incredible advances in generative AI, and people are excited about it. But in our research, we've learned that many people are still forming their understanding of this technology. Many people are not fully understanding its capabilities. They don't understand how their data may be used to improve models, or simply how best to craft the right input for the results they need. Developing an AI product that supports people as they explore and understand its capabilities and limitations will be critical to its success. And this involves understanding the user's intent, the tasks they hope to accomplish, their familiarity with your product, and how much domain expertise they have. In order to do so, people need better tools to understand the AI system. And this can come in the form of affordances for refining inputs, controls to modify outputs, and simply helping people develop the habits they need to verify outcomes. Which brings us to our first principle. We design for user autonomy by providing user choice and control. And this is by considering their tasks, their expertise, and the effort it would require them to steer the AI system. And to do this, we recommend 4 different approaches to put the user in the driver's seat of your product. And they are configuring the AI, refining inputs and outputs, choosing output options, and opting out of AI features. Why is this important? It's easy to rationalize automating tasks in the spirit of efficiency and productivity. But in some cases, people may want to remain in control of their task. For instance, if the stakes are high, whether that's financial, emotional, or there's a risk of loss. In contrast, low cost and low stakes tasks are where people may prefer automation. Knowing when to automate and when to leave control with the user is the key for building helpful AI products. And this requires designing experiences that focus on aligning people's intentions with their desired outcomes. And we can do this by providing people the controls to configure their AI. For example, in Plannerific, our hypothetical event management app, the event planner is organizing a party and customizes an event agent, giving it a name, a personality, and even allowing it to act on their behalf. Which means a guest who is asking for directions to the party will get a response from the agent instead of the host. As people become more familiar with your AI product, their needs and expectations of it will evolve. One way to ensure that outcomes remain relevant over time is to give people the features that help them refine inputs and also direct the AI in alignment with their needs and preferences. Let's say in Plannerific, the event planner is chatting with the agent about outdoor venues for a birthday party, and then switches to discussing ideas for party themes. Now, to highlight this shift in conversation, a system dialog can appear to confirm that change and also allow the user to edit the topic and review any previous instructions given to the AI system. This allows the user to course correct and pivot directions to make the outcome more aligned with their intent. Because of generative variability, we need to help people explore and compare AI outputs while encouraging them to verify outcomes. Giving people the tools to evaluate whether an AI outcome is helpful or not promotes agency, healthy skepticism, and a calibrated trust in the AI's capabilities. To do this, conduct user research early and often. Establish metrics for defining high-value outcomes, and define encodable thresholds for which outcomes should be shown to the user. Now, let's say the event planner asks the agent, is this menu safe for a children's birthday party? A yes or no response would be too simplistic since safety could mean any number of things. Instead, the AI system needs to show the most important conditions to determine what makes that menu safe. And in this case, it means showing outcomes related to food allergens, healthy food options, and food handling, which can help the event planner make informed choices about menu safety. Designing your AI to be thoughtfully integrated into people's workflows means they need to be able to control when they use the AI features and when to opt out of it. For example, people do not always feel comfortable with data collection. And in many cases, they may not even be aware that their data is being used to fine-tune the model. So, explain your data practices and offer the controls to manage that data. And this might include settings that explain to people how their data is being collected, stored, and used, settings to opt in and out of data collection, and secure incognito experiences. In Plannerific, let's imagine that users can toggle on incognito mode, and data from these sessions are not collected for feedback or training, and they're not associated with the user's profile or history. Now, Mahima, how might we navigate data and model practices with generative AI?
Thank you, Sally. So up to this point, several responsible AI practices have emerged. And we've learned that as an AI product scales, we can expect it to be used in different ways, in different socio-technical contexts, and in new knowledge domains. When people use generative AI, they can use it for new tasks, generating new input data. When they select model outcomes, they're labeling output data. But the information in this rich human-in-the-loop process often comes after launch, and the impact of an inadequate data or model building practice may not be visible until someone reports a poor product experience. By front-loading this human-in-the-loop process, we can dramatically change product development. When we understand how people frame problems, especially when they interact with an AI system, we can start to see similarities and differences even within the same task, which can, at minimum, help us make some optimization trade-offs. Good models rely on good data, and good data is informed by an understanding of real user needs, which is why our second principle is essential for responsible AI practices. We need to align our data sets and models to people's interactions with AI systems in real-world contexts. As early as possible, ask people to interact with your models, even if these are low-fidelity prototypes of your AI system. And you can do this with relative ease using tools like Google's AI Studio. Testing with potential users and experts can help you gather prototypical input and output data that captures real-world nuance. This can shape your user journeys, your data collection and model evaluation efforts. For example, you might utilize this data to generate synthetic data for supervised fine-tuning, to refine your test data for fairness evaluations, and establish your interaction design policies. In some cases, you might even be able to identify those rare but critical events in which your product can fail. A key thing to ask yourself in your quest for AI and data alignment is, what do people want your AI to do for them? And how are they conveying this to the AI? Users will frame tasks and instructions in intuitive ways So look for patterns in your input data for when your model doesn't perform as well. ML teams can use these patterns to design data for tuning and adaptation, and UX teams for error recovery and input refinement. Inversely, understand which outcomes people prefer and the model behaviors and influences that they expect. Look for outputs that people find undesirable or unexpected, or behaviors that cause confusion between the inputs and the outputs. The outputs that people choose are useful for building post hoc preference models, defining qualitative standards, and for generating hypotheses for when models underperform. One tool to test your hypotheses is the Learning Interpretability tool, or LIT. It's available in the Responsible Generative AI Toolkit. Of note, LIT's Sequence Salience module explains the relationship between inputs and outputs. It's quite simple in how it works. You enter your input prompt and you choose an output sequence to explain. LIT will compute salience scores for each token, and you can visualize the influence at many levels: words, sentences, lines, and more. Now, LIT is particularly suited for complex debugging tasks in which you need to visually identify important parts of your prompt, errors, or rapidly iterate on prompt design templates to improve model performance. Now, the session would be incomplete if we didn't speak to synthetic data, because generative AI enables scaling limited data points into nearly infinite synthetic examples. But despite all these benefits, synthetic data can often lack variation or contain really ambiguous data points. This example highlights the ambiguity of the input sequence, "Is this vegan?" This query might mean allergies or dietary preferences, but it describes the kind of nuance that's necessary in synthetic data. For this, validate your synthetic data against prototypical data with human raters. Check that your data is representative of the problem space without overfitting, that it contains a good distribution of positive and negative examples, and that it sounds natural in multicultural contexts. Prototypical data can also ground your adversarial tests in real-world behaviors. We acknowledge that it's nearly impossible to get 100% coverage of all possible adversarial tests, but it is important that your AI systems be tested for the most harmful and the most common of these. In fact, this is going to be a lifelong endeavor for many products. A good rule of thumb is to start with community engagement. You might deploy public challenges to test systems and seek global input. Use this as a launchpad for algorithmic and expert red teaming, in which domain experts test for a range of behaviors that include fairness, security, and dangerous capabilities like persuasion and self-reasoning. To enhance red teaming efforts, consider using tools like auto-raters, which provide confidence scores and reasoning for better evaluations. For this, we created LLM Comparator, an interactive visual tool to visualize auto-raters in your evaluations. You can compare outcomes from multiple generative AI models and understand why one performs better or worse than others. And this can be especially valuable in high-stakes scenarios where user safety is paramount. But user safety is an end-to-end endeavor. Sally, can you walk us through ways to tackle user safety?
Absolutely. People entering the generative AI user journey are experimenting and testing with the tools. They're writing and rewriting prompts, they're crafting inputs and refining outputs. And this process of exploration and discovery highlights the rapidly changing nature of generative AI. As these models become more sophisticated, so do the risks. So our third principle is that AI products should have a multifaceted safety strategy that evolves with the technology and people. And this means we need to be proactive in planning, adapting, and changing our safety strategies, whether that's in building products, user experience, or models. When developing safeguards to ensure a responsible product, consider the varying risk levels that users may bring with their use cases. These use cases can range from simple, low-risk prompts such as, "What are some ideas for lunch?" to high-risk scenarios. like asking the AI system for medical advice. And in this case, the model's authoritative response in this high-stakes scenario is what makes it potentially unsafe. And many people who are unfamiliar with generative AI start with simple, low-risk questions as a way to understand the parameters of the system. But over time, they engage in more sophisticated dialogue, exploring complex and risky scenarios. In fact, low-risk scenarios can actually be high risk depending on the context. And AI systems can't account for all the complexities that people bring. So let's look back at the food allergy scenario and say you have a classifier to detect if a menu has allergens. In this case, the guest is concerned about a shellfish allergy and is asking the agent about the menu. Now, there are several scenarios that could occur. First, if the model accurately detects that there is no shellfish in the menu, then the UI could show a verified allergen-free badge. Now, if shellfish is accurately detected in the menu, then a risk disclaimer could be shown to the user. In riskier scenarios, you can imagine, let's say the model says the menu has shellfish, but in actuality, it does not. In this false case scenario, someone skips a dish they could have eaten, but they still go home healthy and full. However, if the model mistakenly indicates that the menu is shellfish-free, but in reality it isn't, now this would have real-life consequences. And there's also the risk of cross-contamination, where allergens are accidentally transferred between foods. And this is something the model may not be able to predict. So if your model doesn't perform well on certain classifiers or inputs, bring in the experts. In this case, it would be chefs, nutritionists, people who have real-world context, and that can further improve the safety measures of your AI system. This scenario shows that just relying on technical measures can create blind spots. And that's why it's critical to have additional risk mitigation strategies such as human-in-the-loop evaluations and user research. Even with the best plans, it's impossible to eliminate all risks, such as hallucinations, inaccuracies, misinformation. So how can we reduce their impact? We need to create affordances that allow people to manage and minimize these risks and help them build habits to verify and corroborate AI outcomes. For example, when AI systems pull from ratings and reviews, add context from trusted third-party sources, such as experts, or introduce social proof. You can also include features like disclaimers and source links to help people to verify the accuracy of that generated content. Or consider using techniques like retrieval augmented generation to show users where the outcomes came from and to provide any relevant context. Speaking of which, if you want to dig deeper into this technique, there's an I/O session on multimodal RAG that we encourage you to check out. Let's say in Plannerific, an event planner sees AI-generated recommendations for wedding venues with verified reviews. We can use RAG to draw information from trusted sources to help the user determine the value of that recommendation. Now, we can't completely prevent all risks, but we can certainly prepare for them. As people adopt your AI product, you may need to evolve your safety strategies, especially considering how people change their behaviors and expectations in response to socio-technical and cultural shifts. Consider the case in which Plannerific is created in the US, but gaining traction in Southeast Asia. The scale of social events in some Southeast Asian countries far exceed those in the US. Now, typical weddings in the US can have 100 people, while in Southeast Asian countries, that can be in the thousands. And let's say a host sends a wedding invitation to 2,500 guests. Because of that scale, these invitations get detected as phishing and are blocked or filtered out. Now, this might be an important safety measure to prevent fraud, but it might also result in a poor product experience, which is why it's important to understand how socio-technical and cultural contexts change across geographic regions, for example, and proactively plan for product experiences that ensure for people's safety now and in the future. We're barely scratching the surface here. Talking about end-to-end safety will take more than the time we have today. When building with open models like Gemma, take a holistic approach to responsibility and consider as many possible challenges at the application and model levels. Google's Responsible Generative AI Toolkit covers risk mitigation techniques to address safety, privacy, fairness, and accountability from an algorithmic perspective.
The toolkit also includes a methodology to build safety classifiers with minimal examples, LIT to investigate Gemma's behaviors, guidance to build transparency artifacts like data and model cards, and LLM Comparator, the new open source tool for the side-by-side evaluation of multiple models. So however we slice and dice it, our best practices always come back to the idea of AI with people. And I think this is because the need for personalization is inherently human. And the capacity to personalize is one of the greatest allures of adding generative AI to a product. Personalizing a generative AI experience is a bidirectional feedback loop. In a handful of interactions with your model's UI, people can get outputs that mostly meet their needs. But when they see that output, they're going to alter their next input. Model outputs are feedback signals for users to iterate and optimize their inputs. The model and the user learn together from each other. And when people keep encountering the same iteration strategy over and over again, they tend to adapt their own interactions to steer the AI model. They build habits and languages for human AI interaction that are bespoke to your products. And this is the basis for our fourth principle. Adapt your AI system with rich multidimensional feedback from people during individual interactions and over time. When designing feedback mechanisms, consider what each feedback signal means. For example, when giving an AI-generated code snippet a thumbs up, does it mean that the developer wants more of that style of code? Or are they saying that the code was elegantly written, or that it met their specific goals? There isn't always a clear link between what a user does and how they want to steer the model. So we should define each feedback signal and see how it can or can't be used to interpret AI outputs and assess model behaviors. Now, broadly, there are three types of feedback: implicit, explicit, and system feedback. Implicit feedback is captured from product logs, and explicit feedback is when users deliberately describe their experience. Your user interface should capture human direction for AI systems using a combination of implicit and explicit feedback signals. And your AI model will need to process and respond to these accordingly. Now, system feedback creates and completes this bidirectional feedback loop. One type of system feedback acknowledges the user input, like a progress bar or a confirmation message. But the second kind involves products giving people feedback to get the best AI outcomes, such as dynamic suggestions or contextual explanations. In our hypothetical application, Develocity, we're asking developers for feedback across the product: bugs, issues, feature requests. This is a very typical pattern in products. You might use this feedback to identify broad themes for your AI's behaviors. Look for relevant instructions, constitutional principles, and safety guidelines that you can tune your AI models with. But when introducing a new generative AI capability, it's more useful to instrument just that specific feature. Asking users how happy they are with Develocity's chat feature is great for measuring developer sentiment. And when we combine this with product logs like the frequency of the feature being used, or the number of turns a conversation lasts, we learn how our AI system actually performs. You might even take this one step further and ask users to rate AI outcomes to understand how well your model performs different tasks. In addition, the feedback that people give on an AI outcome can help them steer the model for better results. Now, workflows often contain multiple tasks that vary in urgency and complexity, which often changes how one might approach them. So, a good idea is to map workflows to see where AI tasks exist and determine the scope of knowledge needed in training and tuning data. Understanding how users navigate workflows with and without the assistance of AI can help you determine the number, the quantity and quality, and the nature of model outcomes. Do people need a wider range of results for exploration or a fewer executable high-quality results? Understanding their motivations can help you determine implicit feedback signals for different tasks and moments to collect explicit feedback to improve model outcomes. In cases where people integrate AI into their workflows, they may start developing a shorthand, and you'll start to see rudimentary examples of this in the linguistic styles and structures that people use to interact with your models. This kind of user behavior is a strong signal for personalization to feed into your models. Another way of giving and getting feedback is asking users to refine inputs. While this might sound counterintuitive, there are many natural places in the user journey where people will need to do something with AI outputs. In Develocity, it would be very natural for a developer to accept partially correct code generated by the model and alter it in the editor, which is a useful rewrite signal. But even with the best feedback mechanisms in place, providing feedback itself is a challenging task. For this, we've created a Python library at Pair called Model Alignment. It automatically revises any text-based prompt through natural language feedback or refines classifier prompts given training data. This can help product teams and people recognize ways in which their inputs can be improved. Now, this technique uses any large language model to turn user-provided feedback into critiques or reasons why the output was undesirable, or kudos, aspects of the output that were great. It also translates user-provided rewrites of model responses into generic constitutional principles to be used by the model. Now, people might want to use your AI for different tasks and decisions. For example, a developer might want to generate boilerplate code or translate a Python function into another language like Kotlin. Your AI product will need to account for moments of change in tasks, but also corresponding user behaviors. One way to do this is to offer controls to the user to decide which interactions the model should remember, and affordances to modify or reset the context window or start afresh. In Develocity's UI, users can dynamically select functions they want included in the context window. But this isn't just a change in the front end. The AI model should also respond to this dynamic change. When using Develocity for code completion, the developer's task will change from writing to reviewing code. And while developers can use the code suggested, they're still responsible for validating and executing code suggestions and ensuring that the code is syntactically and functionally correct. Adding AI can change the tasks that people perform, how they perform those tasks, but also the cognitive load involved. If your AI model's outcomes are consistently very similar, then it can be cognitively demanding to identify what's different or which output is best. In these cases, consider signaling confidence, groundedness, or accuracy to support decision-making. Develocity shows users how grounded an outcome is in the style guides and resources that developers frequently refer to help them evaluate AI outcomes. Now, if your model's outcomes diverge too much, this can also overwhelm the user. Your product might display a similarity metric as system feedback, but you could also offer micro-interactions to refine inputs or capture feedback for model alignment. Now, in enterprise organizations, it's important to keep the knowledge in the AI system updated and preserve code hygiene. This can create quality and productivity bottlenecks if it's not evaluated at the right time. So developers will still need to follow organizational practices like getting code reviewed with another developer or letting the reviewer know which parts of the code was actually generated by AI. So after using Develocity to generate code from a comment, it may be necessary to introduce an interstitial code review step that ensures quality. We'll also need to decide how we're going to indicate edited and unedited code. Now, this highlights that the design of an AI feature needs to factor in multiplayer workflows, organizational practices, and dependencies that impact AI capabilities. AI changes workflows, and workflows change AI. So when people decide to use an AI product, they often bring expectations of benefit and performance that AI needs to deliver. AI can amplify human experiences and expertise, sometimes in the most unexpected of ways. But the efficiency gains from AI are not always cheaper, nor does adding AI automatically assure a more utilitarian or enjoyable workflow. In reality, the AI products that people tend to prefer are ones that seamlessly integrate into their everyday workflows without taking away aspects that they enjoy. This brings us to our fifth and final principle: create helpful AI that enhances work and play. It enhances aspects of work and play that people like and even love about their workflows. But the million-dollar question remains: how do we create AI that people find helpful? There's no one right answer, but a first challenge is to decide how generative AI is going to show up in your product. To get started, you might tailor your interface to make it relatively low effort for a variety of people to construct multimodal prompts. But keep in mind that not everyone can articulate their tasks, and many tasks just don't translate into the written word. Leverage a variety of components and use language so people can enhance their approaches to tasks that they enjoy. And this should be usable by people who are in a hurry, who are neurodivergent, or have trouble articulating in a particular language. The center of collaborative interfaces are turns and not just text. So giving users a history of their interactions can help them retrace their own trains of thought as they iterate on ideas and tasks. This can help them establish cause and effect relationships between inputs and model outputs. For this, we need to make multimodal outputs just as functional and useful as inputs, and offer both global and turn-specific controls. Now, global controls should be persistent and usable across turns, like moving back and forth, undoing, redoing, reverting to a previous turn. Turn-specific controls are transient and shown only when the context demands it, often in the form of micro-interactions. These give people fine-grained control over their individual inputs to steer the model in different directions. It's equally important to seamlessly blend AI into the interaction paradigms that people expect and often love about your product. When people can concretely experience the value that AI has to deliver over and above the value they already receive, they're more likely to use AIs in ways that they find helpful. For this, look for familiar touchpoints and UI metaphors. Unfamiliarity can make it harder for people to use your AI effectively, potentially degrading their understanding and trust in your AI, no matter how good the AI outcomes are. Here, Develocity uses a simple shortcut @Develo to invoke AI-assisted code generation in people's workflows, leveraging muscle memory that developers might already have. Now, in Develocity, there might be some scenarios where users expect intelligent autocomplete and other cases where they prefer on-demand code generation. But both of these happen in the code editor. So AI capabilities should be surfaced at moments when people have an immediate use for it. This helps them understand how to interact with your AI feature and how they can use model outputs. Asking a developer to change over to a conversational UI for writing code can sometimes break their flow of thought, introduce more errors, and reduce overall efficiency. Early and rapid prototyping can help you de-risk your AI feature to ensure that it's helpful and it isn't a distraction. You'll find ways to progressively alter your user interface so people can acclimate to the use of AI in their workflows. In this example, Develocity uses filters, chips, and dropdowns, each populated with sensible contextual examples so developers can complete their expression without breaking flow. So to summarize, helpful AI is easily controlled and steerable without reducing the value that your product already delivers. Your interface might need to be uniquely tailored to your AI functionality so people can intuitively understand what they can and can't do with generative AI in their workflows. Instead of building a persisting full-featured AI capability, you might just need to blend AI into existing features that can be significantly up-leveled with AI. And in addition, in high-stakes contexts, or when AI just isn't the best solution, you might want to ensure that there are fallbacks and alternatives, which might look like ensuring back compatibility, offering older AI functionality, allowing users to proactively limit their use of AI so they have the space they need to migrate over to newer AI features. And it's also important to ask, what AI controls, data settings, safety checks, and feedback solutions do we need in place before we can safely deprecate an AI feature? Because sunsetting an AI feature should be done with the same care that goes into deployment by systematically applying all your responsible AI practices.
We're at the finish line now. And to recap, we've outlined 5 product principles that are the starting point of our journey for responsible generative AI. To bring these to life, we encourage you to adapt these principles to suit your users, your products, and your organizational values. There's so much more in the People and AI Guidebook than what we've covered here today. So we invite you to dive deeper into these topics and read at your own pace.
Creating people-centered AI means putting people at the center of your product and practices. So it wouldn't be a bad idea to read this with your team. We hope that you're able to incorporate some of our guidance into your practices, and we would love to hear from you about how that goes. For more, check out pair.withgoogle.com/guidebook. We're really excited that you're making this a part of your work, and thank you for sticking with us through this session.